Welcome to the lecture on atmospheric aerosol part 2. In this lecture we are going to discuss different types and their sources of aerosols. Okay. Now, one thing that should come to your mind, that what would have been the primitive atmospheric aerosol composition, right? This is very important. In order to answer this question, what you have to understand that how these aerosols are formed or what are their sources. So, this is very important. In this previous slide we will discuss this one. So, there are two types of atmospheric aerosols, one is called natural and other one is called anthropogenic aerosols. In the natural aerosols, there are limited and their contribution is becoming less compared to the anthropogenic aerosols. This should be very clear to your mind. And these natural sources, they are prominent or they are generally found close to their sources. For example, among the natural sources you have like sea salt or sea spray. So, if you go very close to the ocean regions, you will see particles because of when the waves comes in the ocean, these waves actually interact with each other and then this is called bubble bursting. So, there is a bubble formation and during this bubble formation bubble burst and these particles are actually called generated in this one. So, they are called sea spray aerosols or sea salt aerosols. One is actually natural aerosols. Now, imagine a situation where you will find the natural aerosols. You will not find in Varanasi, you will not find in Delhi, you will not find in Lucknow. But if you go to close to Mumbai, Chennai, okay, where or Goa, close to the beaches where you have lots of coast of Odisha, you will see the aerosols that is dominated by the natural aerosols. Then second natural source is usually called as a volcanic eruption, but volcanic eruptions has become less as we know, and we have been having lots of actually volcanic eruptions earlier, but now the volcanic eruption has reduced and then probably the intensity as well has reduced. You have to imagine two things here. Volcanic aerosols, they are actually episodic event, they are not coming every day, they come once in a few years or once in a 10th year or maybe sometimes. But if depending on the intensity of the volcanic eruptions, these effects of the volcanic aerosols can be actually localized or it can be a global or actually on a regional scale. So, it depends actually that what is the intensity of the volcanic eruption. Okay. Then secondly, sea salt aerosols. Now, another very important thing, any natural process will not contribute much, will not be much harmful to us compared to the anthropogenic one. This is very important and this is why I am emphasizing, because we are contributing a lot in the natural anthropogenic in the anthropogenic aerosols, and natural contribution remains almost similar, not varying much, but their composition. But if you see the percentage contributions from the anthropogenic and natural, it has been actually very much. And in the anthropogenic aerosols, like you have vehicular emissions, you can see, you can imagine a situation that if somebody is you are biking or you are walking or even you are driving, if the front vehicle is putting lots of black smokes that is coming, gases that are coming, actually that is actually a toxic gas plus pollutants plus particulates plus all the things are there in that one. And one of the very important thing is actually carbon monoxide that comes in that one. Of course, black carbon and organic aerosols will come in that one, we will discuss that one. But just to see that if you go in a very crowded place and where the traffic intensity is very high, you can feel that by your nose itself that actually something is actually not good, and that is because you are smelling lots of CO, carbon monoxide, which is actually kind of very toxic gas. So, this is one thing. And then actually when we say aerosols, because this is CO is a gaseous form, along with that emissions you see lots of dust, smoke is coming, those smoke particles, they contain lots of organic aerosols and black carbon. So, that becomes very important. And then industrial pollution, industrial pollution is contributed and has been contributing a lot to the sources of aerosols. So, now you can imagine a situation, what would have been a primitive composition. So, in the primitive it would have been dominated by natural sources if at all, okay, it was higher, and anthropogenic should have been less. Okay. But if you say today's situation, what will be the case? In today's situation, anthropogenic natural sources are actually less and anthropogenic are contributing more. So, if I just go back to this logic and I ask you that what would have been the composition of the atmospheric aerosol, of course nobody has, because we really do not know that, we do not have samples of that time, but we believe that it must have been dominated by sulfate aerosols, for example, little bit nitrate because it is also coming, and then sea spray, okay, sea salt, calcium will be there from there, you can have magnesium and you can have sodium and chloride. These are the things that you will be having from the primitive ones. Okay. If the atmosphere was primitive, because the anthropogenic contributions were very less there. And another very important thing is that these aerosols, these natural aerosols, they mostly, I am using the word mostly, they mostly scatter the radiation. What they do? They scatter the radiation. And when they scatter the radiation means they will reduce albedo, they will increase the albedo. And when they will increase the albedo, the radiation that is coming to the surface will be less, and then therefore you will having a cooling atmosphere. Now imagine a situation, why we say that today's the temperature increase in the temperature is contributed by the anthropogenic sources or anthropogenic emissions. It is very clear, because before industrialization or before anthropogenic emissions came into picture, the aerosols, even those the aerosols that were even there in the atmosphere, which are actually of course pollutants, but they were mostly scattering in nature. So, if they are scattering in nature, they were pushing back the radiation back into the atmosphere. So, that they were actually cooling the atmosphere. Today what is happening? We have a dominance of, let me see. So, we have dominance of this one. So, this we have like black carbon particles. You have CO2 that is increasing. GSG is actually like then you have CH4. You have tropospheric ozone that is also increasing. All these are actually contributing to the increase in the temperature. So, this is a very big problem for all of us, because of this increase in the temperature, because of the increase in the industrial emission and anthropogenic emissions, to be more precise. The contribution of the absorbing species has increased in the atmosphere, which has led to the increase in the temperature, and this precisely also very well collect with the temperature increase in the temperature record that we see. We will probably have or we discuss in this one lecture. Okay. Now this is important. So, I said that these aerosols, what are the components of aerosols? Okay. I'm sorry, one source I missed there. So, we will also have actually like mineral aerosols in the natural category. Okay. Because mineral aerosols is I did not put there. There is a mineral aerosols is also very important. Okay. So, mineral aerosols, because you have and this also imagine a situation, there was a cooling in the atmosphere, the temperature was low. When the temperature was low, what will happen? When the temperature is low, soil will be bonded. It will not be easily eroded. You cannot remove the soil particles from there. But when the temperature increases, what will happen? The soil becomes brittle. Soil becomes brittle. The soils become brittle, and when soil become brittle, winds, you have winds now that will come into play. So, if the wind speed is increasing and you have a temperature is increasing here, these soil particles that were there already, this will loosen actually, and with these winds, these particles can be taken away and they can be transported to some other locations. So, this is importance of mineral dust, and of course, because the other thing is that we have already like agriculture activities, you have agricultural activities. What will happen? Agricultural activities you have to actually do for the farming. You have to prepare your soil, or agriculture field you have to prepare for sowing, and during that process, especially for example, if you are preparing for the right now, you will be, most of the farmers will be preparing for wheat grow, wheat. So they will be sowing wheat. So these particles can also be ablated. Okay, I mean they can be actually, they becomes brittle and they comes into the atmosphere. And then other source are actually like we also having a few more source actually like road dust in the urban areas, that dust that is already there. Then you have a construction and demolition activities. I am discussing these sources. These sources had not been still prescribed in the title actually. So when we talk the contribution, but somewhere down the time we are working and we are coming with this one, that these contributions becomes very important, especially in the urban areas. Urban areas, road dust contribution and construction and demolition activities, they becomes very important, because you are getting lots of infrastructure. Roads has to be built. The roads has to be built. Then what will happen? You have to transport soil from one place and put it on the road actually below, and then on that one concrete, then different layers will be formed. So what will happen when during this process you contribute this one, and then road dust in the urban areas is becoming very important because they are not transported somewhere else. Then you have a construction and demolition activities. New constructions are coming up. You have to bring cement, you have to bring sand, balu, and then mitti, gitti, all those things you have to bring. They are actually coming into the urban areas. They are actually used for some other purpose, for the purpose of constructions, and during the demolition activities, they are actually the houses are actually either, if the houses are not in good condition, they has to be demolished. Okay, new construction has to be there. So they contribute significantly to the urban air pollution. We will come to this one later, that what are other composition of this one, but you can see, if I can remove this, how should I remove this? Okay. So if you see here, if you can still read the slides, so this is a different composition, and I think I will have different lectures on the mineral dust, carbonaceous aerosols, volcanic aerosols, eruption, and then you see in between you see sea salt. Sea salt is basically considered as sodium chloride and nitrate. Of course, you have calcium and magnesium that is coming from there. Then another category you see here, nitrate, sulfate and ammonium. These are also actually, these are part of kind of ions actually. So they are actually called anthropogenic ionic species. They are actually tracers for anthropogenic sources, because why they are called actually tracers of this one. This is when you don't have, when during the industrial emissions you will emit SO2. For example, you have sulfur dioxide gas. If the industry is using coal, what will happen? If the coal is burned, SO2 is emitted, and what will happen? The SO2 concentration will keep on increasing. Concentration is keep on increasing, but one very good thing that again I thank nature for its creativity again, because this sulfur dioxide is converted actually into the sulfate particles. Okay, of course not directly sulfate particles, it is converted to sulfuric acid through various process. We will discuss this one, and this becomes part of atmospheric aerosols. So this is very important that we have to consider, or we should consider this one, that how these sulfate particles come into the atmosphere, and this sulfate and similarly the NO2. NO2 is actually mostly NOx gases we talk about. They are coming from the so NOx is coming from the vehicular emission, for example. So lots of vehicle density is increasing, so they have been put into the separate category. But if you otherwise there are actually 4 categories: mineral dust, carbonaceous aerosols, I mean, if you generally divide components of atmospheric aerosols, these are the broadly definition, and types of are the sources of aerosols, then we generally call it in natural or anthropogenic aerosols. And then once you have this carbonaceous aerosols, that is how they are produced. During the carbonaceous aerosols, they are as I discussed this one, that you can directly have a primary organic aerosols or primary carbonaceous particles, and then you can have secondary carbonaceous particles. We will have different lectures on this one, so do not worry about this one right now, and what is the secondary organic aerosols, how they are formed, but I will give just some idea about this one. Okay. So now I just to give you more basics about that, how the composition would look like. So I said that the sources, I take that natural sources. I said natural is actually like mineral dust. Mineral dust is mostly mechanically derived, and the most of the composition is is dominated by calcium, magnesium, iron, and silica. These are the three different components here. These are not the only four, there are many actually, but calcium and silica becomes very important in this category, and they contribute significantly. In fact, we use calcium as a tracer to calculate that how much dust will be there in the atmosphere. Okay, so this is important. Then you have volcanic aerosols. During this volcanic aerosols, we will have sulfur dioxide that is coming in the atmosphere, and you have dust that is coming in the atmosphere. Sea salt spray. So here you have actually different gases plus dust, ice particles. Volcanic ice we call it. Okay, so you will have volcanic ice here. Volcanic ice. Okay, and here you will have mostly the particulate form. So here you don't have gaseous form, here you will have only particulate form, but here you can have gaseous as well actually. Forest fire, there is actually a very kind of debate, or people talk whether the forest fire can be considered as a natural or anthropogenic. Now imagine a situation, if the forest fire is happening just because of the increase in temperature, and the burning is happening or the fire happens because of its own, there is no contribution from the individual or anybody third party, then this forest fire will be called as a natural source. But when we are talking that when we are doing land clearing, for example, we are land clearing for agricultural purposes, okay, agriculture activities, what will happen? The person who is actually seeing, okay, small bush are there or some small plants are there, they will cut it, or actually because the forest department, they will not allow them to cut it. What will do? The nearby area, they will just put the fire, actually matchstick, and then once the fire is on, it can take a very big problem, and this happens actually. So this mostly in the forest areas, this forest fires becomes very important in some of their cases. You can have Amazon fires, which becomes uncontrollable. Even in India, we have actually, if you go to western India or if you go to the Himalayan fires, they have been reported that they can reach up to the albedo, and they can go up to the 4 to 5 kilometer in the atmosphere. So that kind of fire has been reported there. So this is another very important source. When we talk about this anthropogenic, generally we say two types are very important. Here you can see the definition, different kind of definitions: vehicular emission, and then industrial sources, then fossil or biomass burning. Okay, fossil fuel or vehicular biomass burning. Here vehicular emissions, when we say actually like we use actually diesel or petrol, DIECL, diesel or petrol. Now because of these things, in order to reduce, the government has introduced the CNG system, and it has become very popular. Electrical vehicles are coming with this one. So vehicular emissions, because when you use diesel and petrols, and when you burn, and because you burn under the condition where the oxygen is not fully supplied or oxygen is deficient, this complete burning will not be there. I think I have a slide on this one, so we will see this one, and it will produce lots of carbon monoxide, volatile organic compounds, and then let me see if I have think it is not here, so maybe in some other slides it is there. Okay, so we will discuss this one. Okay, so you have carbonaceous aerosols, and because diesel and petrol engines, they were giving lots of emissions and then they were contributing to air pollution. The governments, several governments have banned. For example, Delhi government has banned that if you are having vehicle more than 10 years, you cannot drive actually. 10 years vehicle you cannot drive in Delhi. So if you are caught driving a vehicle that age is more than 10 years, you will be fined. This is another very big problem, okay, because India is a kind of developing country, so lots of activities are happening. Transport has to be there. You have to transport your food, everything, activities you have to do. You have to transport people from one place to another place for working. People use their own vehicles, okay. So, and there is actually some problem because we don't have a very good transport connectivity, or the transport system is not very good as compared to as in the developed countries. So they have developed this one, and in a way, in some sort of time, we need to develop our own what you call transport system that is very manageable, and people, it is manageable, affordable, and it doesn't take much time. So for example, in Ahmedabad, there has been actually BRT construction has been there. So bus rapid transport. So in this one there is a separate lane for the transport, bus transport that is happening. If you take bus, you don't have to go into the queue actually, that will go, a separate road is there. So that kind of activities are contributing significantly, that people are using that one because they want to. Delhi metro railway services. Metro railway services are one of the very good examples. Then using CNGs and EV vehicles that are coming, they are also going to contribute less to the pollution, but at the same time, air pollution of course, but at the same time, so what will happen to the electrical vehicles or the batteries that you are going to use there. So it will be another big problem there. Typically how they contribute and how much they contribute, you see, I say here organic carbon, and this is organic carbon. You have organic carbon here, and this is actually black carbon or elemental carbon. Don't be confused here, I will discuss these things in details again. And then you see sulfate here, and then remaining you see mineral dust. So it's dominated in the urban areas, is mostly dominated by this carbonaceous aerosols and then sulfate. You see these two contributing about 60% almost, right? This is very important. And furthermore, if you just see particulate matter in the Boston, if you see here, this is also here you see the composition. Here it is organic carbon or vehicular emission is about 30 to 35%, but here in the kind of Boston, if you see about 50% or 45%. So that is contributing a lot. What are the sources and different things we will discuss in coming few slides. Okay, this is very important here. We have been talked about. We have been talking different things here. You have a desert here. So from the desert you have a mineral dust that will be suspended in the atmosphere. You have ocean. Not only from the ocean, not only you have I don't know how it is. So in the ocean you will have dimethyl sulfide. That gas is there, and this dimethyl sulfide is converted to the sulfate aerosols. This is another very important source for sulfate aerosols in the oceanic regions, apart from the sea salt spray. Okay, and then you have biological particles, organic matter, sea salt spray that is already here. Then from the plants you can have biologically active particles, and then secondary organic aerosols that is coming here. And if there is actually forest fire, volatile organic compounds will come here, and then secondary aerosol formation can happen there. Wildfires can contribute here again to the smoke, and then volcanoes are given here. So very good example of this one. That paper is actually in Science 2007 by Andrew. This is very busy slide, but very important slides. I think what we'll do here, but before I go into this one, let's discuss that what are the sink of aerosols. So we talked about the sources of aerosols and what are the sinks. So sink, as we say, because it is in the atmosphere, what will happen? Atmosphere, there are only two processes that is happening. Either it will be dry deposition or it will be wet deposition. So either it is deposited when the deposition happens by rain or snow, then it will be called wet deposition, and when it is deposition by its own, then it will be called as a dry deposition. Now the point is here important that whether it is a dry so this is actually like dry and wet deposition that will happen. We discuss this one. Wet deposition, how the dry deposition will happen? Deposition directly due to the surface without any aid of precipitation. There is no aid of precipitation. How it will happen? It will have happening by the gravitational settling. So if the particles falling under the gravity, if the particle mass is m, the force, that downward force is actually m into g, and m we know what is there, m is actually 4 by 3 pi r cube into, this is volume, so m is actually volume into density, so volume into rho. Okay, so this will be into, you can calculate here, into g. So this will be force that is acting on this one. Now this force, you can see this force is directly proportional to the cube of r. So for the bigger particles, this force will be much higher. If the particle size is smaller, the gravitational force that will be less, and then gravitational force will be less, particles will not be deposited. This is very important concept. So because when I say, now imagine a situation, and if you just recall previous lecture, we has a dominance of fine mode aerosols. Okay, when we talk about the number, the dominance was because of the fine mode particles. So fine mode particles will not be deposited much, and in comparison to this one, if you just calculate the volume size distribution and mass size distribution, this was shifted toward the coarse mode particles. So because you have coarse mode particles, this can be deposited, fine mode particles will not be deposited, the deposition will be very less. Okay, the important and the very significant source is actually via wet deposition, and here the most effective removal pathway of aerosols involving water, because when you have the particles are there in the atmosphere, water is falling on this one, and then this water droplets will interact with the particles and they will scavenge actually, and then rain out. This is also happening two ways. One is called rain out in cloud scavenging, okay, and rain out or wash out. Okay, so rain out, that is removal process of a cloud condensation nuclei that is happening in the cloud itself, and it removes only cloud condensation nuclei. Wash out is the removal of aerosols by the cloud droplets, especially when the actually particles are falling, and especially on the upper layer. Sweep out or below cloud scavenging is very important for here, because in the most of the aerosols are concentrated in the troposphere. So say around 0 to 2 kilometer or so, and your cloud is forming somewhere around say for example 5 kilometers, your cloud is forming there. What will happen? So the cloud is forming, it will do the rain out or in cloud scavenging. Then at the same time down below it will be actually doing wash out by the scavenging aerosols, right, in the cloud itself, and then sweep out because all the particles are removed in this one. So these are the three different, just remember the terminology because it is confusing. So this is very important that you should remember this terminology. I think I have discussed these properties of the atmospheric aerosols. So I just quickly go through this one. Physical and chemical properties. Hygroscopic physical properties, we generally talk about hygroscopicity, size, number, surface area, shape, coagulation, condensation and optical properties. But I must say that both the chemical and physical properties, they are very important for the atmospheric science. So you need to understand the physical processes as well as chemical processes if you want to understand the entire process. If you just want to do only the chemical process and you don't want to study the physical process, you cannot understand the complete atmospheric aerosol system. So you have to understand this one. Okay. So in this lecture we have discussed about the sources of the aerosols, their properties, how they are derived and how much they are contributing, what would have been the primitive atmospheric compositions, and how we also discussed about the importance of the atmospheric aerosols, like direct, indirect effects, and then radiative forcing, then cloud albedo, all the things that we have to discuss, we have discussed in these lectures. And I think in the next lectures we will be mostly focusing on the different components of the atmosphere, like natural dust and then carbonaceous aerosols, sea salt, how they are formed. I think I will have one lecture on each of these topics. So this is little bit chemistry will be involved, or some chemical reactions, very basic reactions will be involved. So please try to read some of the things on this one, and then we will discuss that one. Okay, thank you so much.